Hey everyone, in this video, I'm going to show you how I created the carbon fiber or forged carbon fiber mold for the tail piece of my subframe. So I'll take you over to the bench and I'll show you exactly how the mold works, what the design process is, and then we will actually start forging the part. All right, so we need to make a mold for this part here. And you can see I have the components here, but let me talk you through exactly how this process works. So essentially this is a bunch of carbon fiber pieces, right? They're cut up into a bunch of 1-inch sections, and this is how we're going to create the part. So to create a forged carbon fiber piece, you essentially need to create a mold for a shape of the part, and then we're going to compress it with a bunch of force and mix it with epoxy to create the part that we're looking for. So when you have a part that you're looking to create a forged carbon fiber piece or a mold of, essentially there's a bunch of different ways you can do it. What you want to do is you want to take the part in its most flat state, and that's kind of where you want the pressure to be. So we need to create what we call a piston to push in and create this component. So obviously if you tried to mold it like this and press it this way, it's not going to work because of the shape of the part. We could, place it like such and push in and create it in this direction. But the problem with that is when you're filling the mold, it will be difficult to fill that perfectly evenly. So essentially you want to do it like this. This is the shape that we want to create for our mold. And then we want to fill it up with the epoxy and the carbon fiber and then create our part. So when you're creating molds, you typically need to have a draft angle. So you need to have some sort of angle on it so that you can pull it all out. Otherwise, you need to have a bunch of pieces. I've chose to do a bunch of pieces of the mold just because then my parts don't have to have a ton of draft on it. And then the draft always makes it a little bit more complex. So essentially to do this shape, I need to create multiple different pieces. So because I'm molding it like this shape is perfectly fine. Typically, obviously, these would need to have draft on it, or the mold would, but that's if you're taking it out of the mold exactly in this direction. If you take it out in a different way with a split mold of some sort, then you don't have to have the draft on it. So essentially, what I want to do is create a mold so that you've got this shape, and then we're going to pull it out this way from the mold, as you can kind of see what I've got here. So these pieces, I can't pull. If I had my, because I'm putting the brake light in here, I need to have a part that comes up from the front side and comes in. So that way, when it's all molded and I go to take it off, I can pull the front piece off the front of it to come out of this pocket. So because I have a piece that's going to come in from the front side, it also can't wrap around the sides here. If I was trying to take the part out of the mold like this and I didn't have this cut out in here, then this front piece could come in and contain these little ledges. But in this case, because I have this brake light here, I need to have a piece that comes up in the front, and I need to have pieces that go over to here, which you can kind of see here. So this is the base section of the mold, and then these are two of the side pieces that will come in and form the sides. What you'll notice is I obviously have holes in here to bolt these on, and in the mold I don't have that. I'm actually going to cut that in after the fact. So let me put this in the mold and I'll show you how it works. So the part's in the mold, and you can see I have this other piece. This is the front piece that I've designed, and it has the cutout specifically for the brake light pocket. So this will go over, it will place in here, and this is what we will bolt into place, right? And that is what's going to create the shape, the outside shape. And it will also create that brake light pocket. So then when we remove it from the mold, essentially what we'll do is, I've got these flanges here that bolted in place, and we've got these bolts in here. So essentially, when those are all unbolted, I'll slide this out, We'll unbolt these side pieces, and then the part will come right out the front. Now, what you'll notice is this section here is quite large compared to the actual part. So when you place the carbon fiber and the resin in here, essentially it's going to, because it's not compressed, it's going to be quite a bit higher than what the actual part is. If you just make your mold the same shape of what you need, you won't be able to compress it enough to get it all tight. So essentially, we're going twice as tall on the piston side as the actual part, because when we put the carbon fiber in with the resin, it'll probably be quite a bit up here, and then we need to compress that down. So the piston, right, which is what we've been talking about, has the shape of the top of this. So you can see this part kind of has a lip to it, and this piece fits underneath the seat of underneath the seat. And so essentially the piston will come in, and as we start compressing it, it's going to compress down, and it stops right where we need to it so that it creates our part. So the piston, these walls in here that fit up next to everything have a 0.1 millimeter gap smaller, because if it was perfectly fit up in, you could hydrolock it, meaning that when we compress this, we're going to have a little bit extra resin in here that's going to need to come out to form our part, and obviously air. We want to get the air out as well. So if it was perfectly sealed, it wouldn't work. So it needs to be slightly smaller so that it obviously can fit, but also allow the resin to escape. What you'll notice on my piston design is I've created these bosses that are a little bit raised. So when it comes down and seals or compresses fully, these bosses will hit on the top of these components here and not seal completely. Because if we have resin coming out of the top of this mold from the compression, if this was perfectly flat, we would essentially seal it completely in here, and then you wouldn't be able to get all of the air and the epoxy out. So essentially what I've done is I've created a small little air gap on the top side as well, so even when it's compressed, epoxy can come out. So now that you've seen the mold, I think it's time for us to start making it. So what I'm going to do, we'll disassemble this whole mold, and then we have to spray it all with a release wax. So we'll spray it with a release wax. We'll we'll probably have to brush some of that release wax in, and we'll spray them all as individual components, not together. And then we'll bolt the entire assembly together, and then we'll start filling it with carbon fiber. I'm also going to link in the Easy Composites video that they did on forged carbon fiber, so you have a little bit better instruction from them. But stay tuned, and let's make some parts.
When designing the mold, there are a lot of things to take note of, and I will link down below the video from Easy Composites where they talk specifically about how to design the mold, but I just wanted to point out a couple small things. So make sure that all of the components to your mold have chamfers or radiuses on them so that you can actually get a chisel in there to chisel them out after the mold's all done. Because when you pour epoxy, you essentially are creating a vacuum in there, and it makes it really difficult to split apart. So much so that like some of these pieces that I have actually broke the 3D print right off. So you definitely want to take that into consideration. I always think creating more parts of the mold is a little bit easier to take apart than trying to use draft and pull them out using the draft, but that's just my personal opinion. It all comes down to the geometry that you have and exactly what you're trying to do. So as far as 3D printing goes, they suggest in their website or on their videos to use PETG and use a 75% infill and like 5 wall loops. With how large these prints were that I have, it would actually have taken so much material. So I did 6 wall loops on the 3D print, and I did like 30 to 35% infill, and it actually worked totally fine. In the next iteration or the next round of forging that I do, I'll probably actually go even less just to use up a little bit less material. But yeah, so definitely use PETG, make sure you use release wax, I printed with a pretty fine resolution, but at the same time, when it was all said and done, I did sand it. So you could probably use like a larger tip on your printer and a little bit more coarse print, and then just make sure you sand it down. For the actual design though, there was one thing that I wanted to point out. In the actual part, I had, this was my piston piece, right? So this was the piece that comes down and pushes in and creates the part. And you can see these parts are kind of already destroyed from taking it apart. But the back side here, this is where the flange lived. So you've got this big flange here, and that's what seats down onto the top of this when you press all the way down. But when I was trying to take this apart, because this piston was actually like stuck in here, it was really difficult to get apart. So what I ended up doing was using like a pry bar to try and pry this out, or like pry it up. But I could not get it out. And that's what ended up breaking the 3D print. So what I suggest doing, and what I'll do in the future, is that the piston itself will be its own part, and then the flange on the backside will be its own part. So when you're ready to pull it off, you can actually like unbolt the flange from the piston, so that you just have the piston piece in your mold like such. And then you can get like a chisel down in between the piston and the main part of your mold, and that should help break it off. I literally had to break the 3D print just to get it off, so I think it's better if you print those as separate parts. Hey guys, I'm getting ready to start weighing out the carbon fiber that I'm going to need for this specific part, but I wanted to run you through exactly how you calculate this. So I've been using the Easy Composites website, and they specify that you got to start by looking at the CAD model if you have one, and you look at the volume of the actual part itself. So in this case, I have, and you want to look at the volume in cubic centimeters. So in this case, my part is 226 cubic centimeters. And then from there, you multiply that value by 1.4 to get the final weight of the part with the resin and the carbon fiber in grams. So in that case, this leaves me with 316.5 grams. And then from there, they specify that you want to split it up in a 60-40. So 60% of the part is going to be carbon fiber and 40% is going to be resin. So you take that 316.5, multiply that by 0.6, and you get 189.9 grams. So I need to weigh out that much carbon fiber. But if you watch some of their other videos, they specify that if you're trying to optimize the carbon fiber for actually even stronger results, you take longer strands of carbon fiber and put in. So I do have a roll of just long carbon fiber strands. So what I'm going to go ahead and do is mark them out the length that I want and cut them, and then I will measure up some of these as well. They say you don't want to go more than 30% of your volume, but in this case, this part isn't super stressed, so I'm not going to go too much. But what I will do is, after I'm done weighing it, I will take half of the forged carbon fiber out into two separate buckets, and what I'll do is I'll lay in the first batch of forged carbon fiber in the mold, and then I'll take those long strands, put them in so they're directly in the middle of the mold, and then fill it up the rest of the way. So we've got 189.9 grams of carbon fiber that will be mixed between the long strands and the 1-inch cut pieces, which I have here. And then the resin weight will be 126.6 grams. They do recommend that if you're in a larger mold to mix up about 25% more resin, just because obviously you'll have some that sticks to the brush, it'll get other places. So, and you always want extra that will come out of the mold. So you multiply that by 1.25 and you get your total resin weight of 156.25 grams. So that's all the math there. But then the other thing that you got to look at is the resin itself that I'm working with. You do mix it 2-to-1, but it's 2-to-1 by volume. In this case, I'm not mixing it by volume, I'm mixing it by weight. And they say you want 100 parts to 46 parts of the hardener. So you do some simple math. You essentially say, I need 158.25 grams total. And then you say that that's equal to 100 plus the 46 for your other parts, which leaves you with 158.25 divided by that 146, which is the 100 to the 46, and that gives you 1.08 whatever, and you multiply that value by 100 to get your epoxy and by 46 to get the hardener. So that leaves me with 108.39 grams of epoxy to 49.86 grams of hardener. So I took you through all the math. I know it's probably a little bit cumbersome or just annoying to look at all the math, but if you are doing it, it is helpful to have all these values and know how to calculate all of them. So what I'm going to do now is I'm going to cut up some pieces of the carbon fiber to length, and we'll start measuring this out. In the last video, I was measuring out the amount of carbon fiber needed for the mold, and I accidentally realized that I weighed it to the resin weight, not the carbon fiber weight. So I have adjusted that. I took some carbon fiber out to match the weight that's needed. So now I'm going to spray the mold with this mold release. It works well with epoxies, or at least it says it does. I haven't used it before. So I'm going to give this a couple light coats. It does say to potentially brush it on, but I'll see how that looks when it's applied. And then we're going to move this inside to do the actual molding. With epoxy and certain epoxies, or in most epoxies, when you mix the hardener in, it creates an exothermic reaction, which just means that it generates a lot of heat. And also with heat makes it actually cure faster. So in a lot of cases, if you get epoxy too hot, it will cure a lot faster than it needs to, and its working time decreases. We live in Phoenix here, and right now it's like 85, 90 degrees already in the garage this morning. So my worry is that if I try to do it out here, the epoxy will cure too fast, or at least the working time will decrease, and I might have issues just getting it all done in the time. So I'm gonna paint this or spray these molds here, and then I'm gonna go get set up in our kitchen. Put down some of this cardboard painting paper just to make sure that I don't get epoxy everywhere, and we're gonna start molding. All right, we've got all of the carbon fiber in there with the epoxy. I think the only thing I would do differently if I did this again was put in less carbon fiber at a time and make sure that it was fully wet. I feel like I put in probably too many clumps of carbon fiber and then couldn't get them fully wet, but we're gonna go ahead and get the piston in here and see what happens. That went on a little bit better than expected. What I'm going to do is I'm going to wrap some parchment paper around here and then get the C-clamps on, just because I don't want to get all my C-clamps covered in epoxy. So I got some parchment paper, we'll get that on, and then we'll start getting the C-clamps on. We're already starting to get some epoxy coming out over here. I can see some over there. I'm just trying to make sure these clamps are even. And you want to do this slowly, because if you do it too fast, you can actually don't get time for the resin to come out, and then you can just break the mold. So I'm trying to go slow. I might let it sit here for a minute and then come back and tighten some more. My battery is about to die on there, so I might you might not see the rest of it, but essentially you can see epoxy coming out already. So we're just gonna keep going around and tighten this until it fully seats, and then we will basically just let it sit for 24 to 48 hours and we're good to go. All right, as you can see, we are fully seated. In the mold design, I remember talking to you about how I had these little posts. You can kind of see one right there. So as I push this all the way down, if I didn't have those little circular bosses there, then you wouldn't have any way for the epoxy to get out. So you need to make sure that you, even when you close it all the way down, you have a slight little gap. That way you have room for the epoxy to seep out. So you can see I actually ended up filling up a little bit more epoxy, just because I felt like I used a lot of it. So there will be quite a bit that comes out, but it's always better to have too much than not enough. So we're now pulling some out. I'm gonna go ahead with a paper towel and try and clean some of this up, but we are completely seated. And then in the next couple days, we'll end up pulling this apart and seeing how everything looks. All right, guys, I was able to get the mold apart. As you can see, it is broken into a bunch of different pieces, which I'll get into a little bit more about how I could have changed the design to make it a little bit easier. But essentially what I ended up having to do is use a chisel and a hammer and some screwdrivers to pull it apart. As you can see with some of the chisels, I had to break some of the mold pieces off. So when you fill with epoxy, the epoxy fills out and gets all the air out. So essentially you have a vacuum trapped in there, and it's really hard to get the part away from the mold. So that's why you use a lot of the release wax. As you can see, a lot of the epoxy that came out between the piston and the actual mold actually just kind of flakes off. You can see it comes off relatively easy, which just means that we had enough release wax on here so that the epoxy didn't stick to the mold itself. These side pieces here, they actually broke off perfectly, so there was no damage to these. So if I wanted to reuse these side pieces, I could. But this mold here is most likely garbage. Obviously the bottom piece where the mold I cared about is actually pretty good. So you could potentially use this, but probably not. The front section is actually intact. I would just need to clean off some of the resin that's on here, but for the most part, we could actually reuse this if we wanted to. So when I made the piston section, so this piece here, I made these little bosses on here so that when you push this all the way down, you would allow resin to get out. And these bosses just weren't tall enough. So the resin that pushed out basically filled up that entire gap, and it made it really difficult for me to get in there to try and pry this out. So when I do this again, I'll make these bosses a little bit taller and allow the resin to get out a little bit easier. The part itself, you can see here, it fits perfectly in the piston piece. So once I pulled this all apart and obviously broke this off of the mold, I was able to just pull these two pieces apart. And you can see that there is quite a bit of flashing that happens around here. So what I'm gonna go ahead and do is start cleaning this up, and hopefully we'll get the part will just look a little bit nicer. There are some slight imperfections. You can see here I got a little bit of voids. In this corner there's some void, and over here there's some. But essentially what I'll do is I will sand this down some more, and then when I have the subframe fully complete, I will do a top coat and epoxy, and that should fill in any of the voids and clean it up. If I need to clean up like this corner section a little bit, I can always print another small piece like this that has this feature in, and then I can kind of fill it with epoxy, push this in, and then it will create that corner all nice and smooth. Another thing to note is that where the piston came down, this epoxy came up the sides of it. So I'll know that whichever side the piston is pushing, that's the side that's going to look the worst from the flashing, and your other side is going to most likely look the best. So when I create the molds for the foot peg brackets or the other subframes, I'll make sure that the faces that are outside are actually the bottom of the mold, and press from the backside. That way it just looks the nicest, and whatever cleanup I have to do, I'll just have to do on the backside, so it doesn't have to be super pretty. So in this case, I'm going to go ahead and start cleaning this up. One thing to note is carbon fiber dust, when you start cutting it or filing it, you do not want to breathe it in, so make sure that you get a respirator if you're going to do any of this work. I have a full face one, just because if there is any dust, I don't want it to get in my eyes either. So I'm gonna go ahead and start cleaning this up, and then hopefully we'll have a nice looking part when we're done. All right, so the part is cleaned up. I sanded it down just a tad bit. So you can see there's still some finishing that still needs to be done. I need to go through and sand it some more. There's obviously still some voids here. I'm hoping that this part will end up being usable, but if not, I can always remake it. It's obviously the easiest one. I'm gonna go ahead and make the rest of the subframe. Honestly, I'm gonna make these foot peg brackets first because they're easier than this one large piece. But once this is all done, I'll obviously get this on here, and we'll get all the subframe, and then if I need to remake this piece, I will. But as you can see, it fits really nice. So we're definitely onto something. It matches the 3D print model that I had, or the 3D print prototype. And we'll see if this is gonna end up being a usable part. What I still need to do is I'll 3D print a template to cut the holes in here so that I can mount to the tapped holes that are gonna be on the inside here. So that's where this guy fits up. So this has been quite the journey here, trying to go through with the forged carbon fiber. So this is obviously the first one that I've done. It's not perfect by any means. I think it's still salvageable. I think if we do a top coat of epoxy over the top of it, sand it down, and clear coat, it'll obviously look really nice, but I'll determine that later on down the road when we get the rest of the subframe done. So the big point of this whole video and this process was checking to make sure that the forged carbon fiber was actually going to work. So if for whatever reason I went through this mold process and I didn't get a usable part, or it just didn't work out well, or the 3D print didn't work, then obviously I would have had to go a different route with the subframe. But since I know that this process works, we can continue making the rest of the components and hopefully in the next few months have a subframe. Just the mold itself took like 5 days to print just for the small piece. So it's gonna take some time for me to get the rest of the mold designed for each side of the foot peg brackets and the rest of the subframe. So that's gonna take some time. It's gonna take a lot of time to print. And then in a future video, you'll see me do each side foot peg brackets, and then we'll do the subframe, and hopefully going forward, we'll have some better looking parts. I think there's a couple things too that I would do a little bit differently. So the release wax or spray wax was definitely really good. It recommends doing 2 coats. I did like 3 or 4 just to make sure that it was covered very well, and all the parts came off pretty easily. One thing I would have done a little bit better is I would have put more epoxy, like painted the epoxy or resin on the mold a little bit more first. I did it on like the bottom coat, but then as you start packing it in, or on the bottom face, but as you start packing it in, it's hard to make sure that you've applied it on all the sides. And that's why I've got some voids on the really outside of the part, is because there wasn't a good amount of resin on the outside and I couldn't wet it down. So if you do this, make sure that you are getting resin painted or brushed on the mold really well before you start packing the carbon in. I would also put in smaller chunks. I was kind of on a time crunch while doing this, which is never a good thing for a project. So I was putting in like a lot of carbon fiber at a time. But I think if you put just a little bit on at a time and make sure you wet it out, it's good. I ended up having to mix extra epoxy. I mean, as you compress it in, the epoxy, if you got too much epoxy, it's coming out. So you definitely want to make sure that if you're making this and you're molding, make sure that when you compress it, you do have epoxy coming out. If you don't have any coming out, there's a chance that you're not compressing it all the way. The mold itself was quite a bit taller than it needed to be. Easy Composites recommended 2 to 3 times larger than the part height that you're trying to mold or compress, which is what I did. I made it I think this is like 1 inch tall. I made it like 2.5 inches or something like that. And it was actually too tall. Not too tall, but I could have gotten away with like maybe 3/4 of an inch shorter, or maybe even shorter than that. Just because as I laid the fibers in and filled it with the resin, it didn't take up too much room in the mold that it needed to compress. It was actually fairly compressed as I was putting it in. So it can definitely be a lot shorter, which means that saves me on materials. So I think this is going to be the end of this video. I hope you guys really enjoyed the process of creating the forged carbon fiber, and I hope to see you in the next video. Please let me know if you have any questions. Reach out here on YouTube or on Instagram, and I'll try to answer any of your questions. But I'm really excited for the rest of this build, and hopefully we can get some more carbon fiber parts made up and get the bike running. I don't know when, but hopefully soon. So stay tuned, and I'll see you in the next video.